All right, we are looking at section 5.2, which is multiplying polynomials. So let's start with some basic definitions. What is a polynomial? A polynomial is a collection of letters and numbers with adding and subtracting in between. All right, now what is a term? Term is one part of a polynomial. So if we take a polynomial, these letters and numbers, and we split into parts, the parts would be called terms. So we can combine like terms. If they're unlike, we can't combine them. But if they're like terms, we can combine them by adding and subtracting them. And then we have one more thing called distributing, which is multiplying terms. So if you remember back in chapter 2, when we were solving algebraic equations, or linear equations, we called them, our first step was always distribute, combine like terms to get rid of parentheses. Now, what are exponents? So we're going to come back to this idea of exponents because it's going to be really important for this chapter. And you're going to hear a lot about exponents. And so what are they and how they work? So an exponent tells you how many times to multiply a number by itself. So 6 to the 3, where the exponent is 3, or we also call it a power, basically says we do 6 times 6 times 6. 5 to the 3 is basically where the exponent is 3, basically says 5 times 5 times 5, which eventually gives you 125. But the main idea right now is to say 5 to the cubed, or 5 cubed, is 5 times 5 times 5. Okay. And this is just a shorthand. For example, if we want to write a number 1,000 times, 5 times 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 5, that would be ridiculous. So one of the things we do in mathematics is, instead of us trying to write 5 1,000 times, we just say 5 raised to the 1,000. And everyone knows what we're talking about because we just say 5 to the 1,000. They know all you did was just figure out how to write the same thing without having to write a whole bunch of numbers. All right. Now, I want to go back and remember something. If you want to add or subtract two terms, they have to be like terms. When you multiply two terms, however, that rule does not apply. You say, wait, hold on a second. How come I can do this for multiplying? Well, let's go back and think about some things. Think about when we were dealing with basic numbers, right? A negative plus a negative makes a negative. When you multiply a negative, you get a negative times a negative is a positive. So it's weird because it's different. We were adding fractions, we had to do things a certain kind of way. You had to have a common denominator. When you were multiplying fractions, you didn't need a common denominator. So adding stuff and multiplying stuff is usually really different. So if you want to add or subtract two terms, they have to be like terms. Like, they have to be like terms in order to add or subtract them. But we're not talking about adding, subtracting. We're talking about multiplying the terms. The only thing that the two terms must have in common is that they have the same letter. So in other words, you couldn't necessarily put an x times a y. I mean, there are exceptions, but you can't usually say x times a y kind of stuff. All right. So to multiply two terms together that are letters, you have to use a basic exponent rule. I want you to look at this, and I want you to notice that when we say x to the 2 times x to the 3, we get x to the 5. Notice that 2 plus 3 is equal to 5. When I do y to the 4 times y to the 6, I get y to the 10. Notice that 4 plus 6 equals 10, right? If I take $4 and $6, I get $10. So notice that that's what's happening. So let's talk about this rule and let's kind of put it together. I want you to kind of see where it comes from so you can kind of go, okay, I know what you're doing. All right. Next one tells you how many times to multiply a number by itself. So how many times to multiply a number by itself is an exponent. X to the 4 is just x times x times x times x. There are 4 x's there. We only write one of the x's, but there are essentially 4 x's there that we didn't write. We just wrote the x to the 4, so we wouldn't have to write 4 x's out. P to the 3 is just p times p times p. Instead of writing p times p times p, we wrote p to the 3. So now let's take something like x to the 3, x to the 4 times x to the 3. So we're going to start with x to the 4. X to the 4 is equal to x times x times x times x. X to the 3 is equal to x times x times x. So x to the 4 times x to the 3 is equal to, and if we write everything out, it's x, start with that, x times x times x times x, x to the 4, times x times x times x, x to the 3. How many x's do we have? Let's count them. 1, 2, 3, 4, 5, 6, 7. There are 7 x's multiplied by each other. What is that? How do we write that out? We write that as x to the 7. Now, let's take p to the 2. Sorry for this typo here. But we're looking at p to the 2. P to the 2 is p times p, right? There's 2 of them. P to the 6 is p times p times p times p times p times p. There's 6 of them, right? So now let's put it together. I got p times 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 p. I've got a bunch of p's here. Now let's count the p's. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 total. Therefore, we have 8 p's multiplied by each other, or put simply, p to the 8. Now, I want you to think about this in the simplest way possible. And this is a very important concept. We had to get this idea across in our heads. This p to the 2 tells me that there are essentially 2 p's. Even though I only see one pictured, or that, there are essentially 2 p's. P to the 6 tells me that I have 6 p's right there. I didn't write them all out, but there are 6 of them. So P to the 6 says there are 6 p's. There's only one that I wrote out, but there are 6 of them. And this is what's going to help us get it, because if we get that concept, it will be really easy. All right. Now, how do I multiply one term by another term? So what happens if I put numbers out in front? Well, let's look at this number here. This is called a coefficient. My coefficient is 4. My coefficient for this one is 2. Step 1, multiply the coefficients together. 4 times 2 is 8. Step 2, we keep the letters the same. The letter here is A. We keep the A. And step 3, we add the exponents. I have a to the 2 and a to the 5, a to the 7. Now, conceptually, here's what's happening. I've got 2 A's right here and 5 A's right here. How many A's is that? that 7 A's multiplied by each other. I have 7. Now remember, if we were adding, if there was an addition sign in the middle of these, we couldn't do it. Why couldn't we do it if there was an addition sign in the middle? Because they're not like terms. But this is multiply. The rules are totally different. And so we can totally do this. So multiply numbers, add powers. Cool. Let's do more. So now we're going to multiply one term by more than one term. Now, when you multiply terms by more than one term, you have to use what's called the distributive property. All right? You have to multiply the term that's in front of the parentheses by everything inside the parentheses. So the 5x has been multiplied by everything inside the parentheses. 5x times 3x squared plus 5x times 2. Now let's go through it real slowly. All right, 5 times 3 gives us 15. How many x's do I have here? Well, I have one x right there. And then over here I have 2 x's. How many x's is that? 3. 1 plus 2 is 3. I have 15x to the 3. Then I go over to my next term. I have 5x times 2. 5 times 2 is 10. And I have an x. That's it. This is just the x. I have 10x. Can I keep going? All right. Can you add unlike terms? No. This is addition. We cannot add those together. They're unlike terms. We have to stop. That's it. That's the final answer. All right, here's another example. You can go back and look at that later. It's example 1, multiplying polynomials. Essentially, it's the same idea. I'm actually gonna skip that one. And I'll go to this one. We'll do this example. I think I have one more example after this. And I'll do the second and third example. All right, we're gonna multiply 2x to the 4th times 3x squared plus 2x minus 5. So first thing we do is we take each of these, distribute, and write out what we're multiplying. So 2x to the 4th times 3x squared, check. 2x to the 4th times 2x, check. 2x to the 4th times a 5, check. All right, and that gives us 2 times 3 is 6. We have 4 and 2, that gives us 6 total of those, x to the 6. 2 times 2 is 4. We have 4 plus 1 gives us 5. And then 2 times 5 is 10. We have 4 of them, and that's it. We have x to the 4, there's 4 of them, x to the 4th. Can we do anything more with that? Well, this is adding and subtracting. So no, because you can't add and subtract unlike terms. You can multiply them, you just can't add or subtract them. And we'll do the last one. So negative 2x squared times 3x squared minus 7x plus 10. Let's look at this situation. I have negative 2x squared times 3x squared. What's negative 2 times positive 3? Negative 6. I have 2 x's and 2 more x's. How many x's do I have total? 4 x's. X to the 4. I have a negative 2x squared times a negative 7. What's negative 2 to negative 7? Our calculator will tell us. It's plus 14. All right, I have 2 x's here and 1 x there. That's 2 plus 1 gives me 3. And negative 2 times 10 is negative 20, x squared. Again, I'm going through it really slowly. I'm just trying to make sure that you know that you can see exactly why do we get these numbers. Over time, hopefully when you practice, it'll become more simple. Maybe it's pretty simple now. I don't know. I'm trying to go through it and be thorough. All right. let's summarize this. When you multiply terms, you multiply numbers in front and add the powers. So this illustrates you kind of what happens. So you kind of look at that and say, okay, I kind of get that. All right. Make sure you remember your multiplication rules. So multiplication rules are a positive times positive is a positive. Negative times a negative is also positive. Positive times negative is a negative. Negative times positive is negative. So just kind of remember those. Make sure you don't mess up on signs. And last but not least, when you multiply one term by a lot of other terms, you have to distribute and multiply each term separately. Notice that I'm writing these out, these separate multiplications out, so I can keep things organized. I'll go back and show you real quick here. Yeah, you can kind of see I'm doing that. I'm writing out different multiplications out separately so I can keep up with it. All right. That should do it. Cool.